Alright, for this problem we have the objective of using an electric field that varies with position to calculate the momentum and position of a charged particle through a few iterations, in this case 3. We are given the electric field E of xyz equals 2z negative x and y minus 4 newtons per coulomb. To start, we're dropping a point particle at the point 1, 1, 1 with no initial momentum, and we'll calculate how its velocity and position change during 3 time intervals of 2 seconds each. The point particle has a charge of 10 microcoulombs and a mass of 10 grams. So to start, we calculate the force, which we can find by multiplying the electric field at the point 111 by the charge of the particle, which you can see here. This is our force. We can then use that force to update the velocity using this formula here. We are given the new velocity of 4 meters per second in the x direction, negative 2 meters per second in the y direction, and negative 6 meters per second in the z direction. We then come over here to update the position, which is given here. We're given the new position of 9, negative 3, negative 11. So now we have a new position and a new velocity, which is the updated version of those quantities after 2 seconds. We basically repeat the calculations again for the second iteration, finding a new F net, which we then use to update the velocity, which we then use to update the position. We are given the new velocity of negative 20 meters per second in the x direction, negative 10 meters per second in the y direction, and negative 18 meters per second in the z direction. From that, we get the new position of negative 31, negative 23, and negative 47. Then taking that, we do the exact same thing again, get a new F net, a new final velocity, and a new position. And after 3 iterations of 2 seconds, the particle is at position negative 447, 81, and negative 191 meters, with velocity of negative 208 meters per second in the x direction, 52 meters per second in the y direction, and negative 72 meters per second in the z direction.